Hello students, let's read this question. What is the prime factorization of 99? Okay, so I'm gonna highlight important information and well, they want to know prime factorization and then a number is given. I like these questions, are very short. Okay, so I just need to focus. We did circle and underline and we box a question. We're gonna elaborate and then after elaborate we're gonna solve. For elaborate, since we're working with prime factorization, I'm gonna bring the anchor chart for prime factorization. And I like to cover my anchor chart so I can refresh my memory on why this is non-prime numbers and why the rectangle below are prime numbers. Just one example. Okay, so for example, the number 6. To get the number 6 back, I can multiply 1 times 6. So we need to look for factors so we can define if the number is or is not prime. 1 times 6 gives you back the 6. And also if you do 2 times 3, gives you back the 6. So right there, I have 4 different factors. And to be prime, it can have only 2 unique factors. Okay, so let's look at the 13. 1 times 13, those are 2 unique factors. Okay, so it's falling into the definition of prime. What about times 2? Can I multiply 2 times something and get a 13? No. What about the 3? No, because 3 times 4 is 12, so that's smaller than 13. But 3 times 5 is 15. So, and I can keep looking and I'm only gonna get these 2 factors. Okay, so now we remember what prime numbers are. Now let's do the prime factorization. Our first step will be to create a tree diagram. So I'm gonna write the label. So I'm gonna write the number that is given, the 99. I'm gonna write it right here. And I always like to get started with the number 2 if possible. So I always look at the last digit, in this case it's a 9. And if it's even, I can divide by 2. But if it's not even, if it is odd, we can't. So 9 is odd. I cannot divide by 2. So now I'm going to try by 3. On the side, I'm going to do 99. I'm going to divide by 3. And see if I get no remainder so I can use that factor. So I'm going to work first with this number here. 3 times what can gives me 9? And the answer is 3. Great. 3 times 3, that's a 9. 9 minus 9, that's a 0. We bring down the 9. Now we divide 3 into 9, that's going to be a 3. Great. So this is going to be a 33 because 33 times 3 gives me 99. And this 3 is a prime number. Okay, great. So I'm just going to keep this number right. Okay, now this number, the 33, again, I check the last digit and it's odd, so it's not even. So I cannot divide by 2. So I'm going to check what other 2 numbers. I'm going to try the 3. And this number is 33 divided by 3. And let's see if I can get an answer with no remainder. 3 times what gives me 3? The answer is 1 because 3 times 1 is 3. We subtract, the difference is 0. We bring down the next digit, which is a 3. 3 times 1 gives me back the 3. And remainder 0. So we can use this 11 as a factor. So I'm going to write in here 3 times 11 gives me back this 33. And 3 is also prime number. And 11 is also prime number, is right there. So I finished with the, finding the factors that are prime numbers. My second step is going to be to write the prime factorization. So I'm going to be adding that label. I added my label and now I'm going to write the factorization. The number given was the 99, right? Okay, so now I'm going to write the factors that I listed in here. I'm going to start with the 3's. This 3 here will be this 3 here. Times, you see this other 3 here? I'm going to write it right here. And the other prime number is 11. And so basically the idea is that these prime numbers, they need to be multiplied so we can get back the 99. 3 times 3, that's 9, and 9 times 11 is 99. So this is our prime factorization, and I'm going to circle this in blue just so we can keep track that this is from where we got them. And now I'm going to rewrite this as a prime factorization. The 3 is being repeated, that's the number that is repeated, and the exponent indicates the number of times that is being repeated. So we write the 2, and then we print the 11. This is our prime factorization for 99. I'm going to put a red cloud around. And I'm going to look at the answer choices for this answer. The first one has 2 to the power of 3, but we have 3 to the power of 2, so it's not working. The 11 is okay, but the 2 need to work. Then here we have a 9, and I don't have a 9. I need to have 3 to the power of 2, because 9, look, 9 is non-prime. So this is non-prime factorization, although 11 is a prime number. 9 we already said cannot be, it's not a prime number, so it cannot be in the prime factorization. This one does, but now this one doesn't work. And then letter D, we have 3 to the power of 2 times 11, and so that is our answer. Awesome, thank you guys.